Okay, part 2 of chapter 2, section 1, relations and functions continued. This time, if you take a look at the graphs that we have here, we're going to talk about how to find the domain and the range of the function. And because these graphs are continuous, if you look here, these arrows mean it continues, goes on indefinitely in the direction of the arrow. You know, all three of these are continuous. We are going to have infinity being involved with this. So look at our directions. It says determine if each graph first represents a function, and then state the domain and range of each graph using interval notation. This is really important that you know how to set up the interval notation. Notice this is circle graph. You know, it has a beginning point, and technically a circle doesn't have any ending point. These points just, you know, just keep going around and around and around on the circle. Arrow indicates infinity. This over here, though, there's no arrow on this end, so this is a definite stopping point. Here's an arrow on this graph. Here's a stopping point on this graph. Same thing here, but I'm going to have infinity here. Here I'm going to have two infinities. And here I'm not going to have any infinities, okay, because I have, it doesn't continue here and it doesn't continue there. So, let's get to it. Determine if the graph represents a function. Well, what have you learned in the last lesson that tells you if a graph is a function, or if a relation is a function if you graph the ordered pairs? Yes, we use the vertical line test. So I'm going to take my marker here as my vertical line, and I'm going to just go right through it. Well, I see that if I draw a vertical line here, that I am going to touch it in two places, one here and one here. So this is not a function. So I'm going to say no, fails, vertical line test. Now, what is a domain? Remember, the domain are the x values. So you have to look at values of x that would be found on the graph of this function. The first value of x is right here. 1 is on there, 2 is on there, not here, but if I follow this up, that ordered pair has an x value of 2. 3 would be on there, somewhere up here. 4, and of course 5. Okay? And in fact, all the fractions in between those integers are on there. And this is going to keep on going. And so this goes to infinity. It starts at 1. We're going to use a bracket because it is included, and we're going to infinity. The y values. Well, if I look at the y values, okay, y's are this way. So I'm going to follow it over. This is a y value of 0. Is it on there? Sure. Here, this ordered pair is x is 1, y is 0. So a y value of 0 is on the graph of this function. A y value, I'm going to put that here. This has a y value of 1. The x value is not 1, but the y is. See? I'm looking over here for my y values. And in fact, all the positive y's are on the graph of this function. And all the negative y's. You know, a y value of -1 would be found here. A y value of -2 would be found somewhere about there. And -3. And -4, and all of the integers in between. So for my range, I'm in fact going from negative to positive infinity. So if you have a question about that, ask it in class or post it on the homework discussion. Vertical line test, this clearly passes the vertical line test. This appears as though it's pretty straight, but this widens, okay, and this will get wider and wider. It's just getting wide very slowly. Okay, so this is a function because it passes the vertical line test. What is my domain? Well, my domain are my x values, so I have to consider what x values are found on the graph of this function. Is -1 found on the graph of the function? Sure, it would be somewhere in there. Is +2 found on the graph of this function? Sure, x value +2 would be down here somewhere. Is 5 found on the graph of this function? Sure, if I continue and go up, eventually they're going to intersect. So in fact, the domain here is negative infinity to positive infinity. The range are my y values. I do have a definitive low point right here and here. And this is a mirror image. This function is an even function. So it's looking as though my lowest y value is here at this value, which is negative 4. There are no more negatives lower than negative 4 that are on the graph of this function for y values. So I'm starting at negative 4, including it, and I'm going to positive infinity. Because notice the arrows again. This means the y values are going to keep going up as well as the x's. The linear function, is it a function? Yes. Again, it passes the vertical line test. The domain here for any linear function is negative to positive infinity. And the range is also negative to positive infinity. You think you're catching on? I hope so. All right, let's go to the next set of 3 graphs. The circle is not a function. It's going to fail the vertical line test. If I were to draw a vertical line somewhere in here, it's going to hit it 2 times. So this is not a function. No. Fails vertical line test. What's the domain? Now remember, the domain are your x values. So I'm farthest left and farthest right for x values. I'm starting at x is negative 2, and it's going to where x is 4. All the other x values are found on the graph of that function. If, I want to know if an x value of 0 is on there, well, sure, up here, this ordered pair would be 0, 3. Okay, so that x value of 0 is on that function. So, well, it's not a function, it's the x value of 0 is found on this graph. Starting at negative 2, stopping at positive 4. The range are the y values. What's the highest value and what's the lowest value on the y-axis? Well, I'm up here, somewhere in here, and my lowest is here. Now this point wasn't quite on 3, so we'll say, I don't know, negative 2.8 to make it a little bit closer. Okay, because 3 hits 3, bam, right up there. And down here, because you can kind of see, let me zoom in. I should have zoomed in before. This point, this part of the circle is not quite on negative 3. You could see it if I zoom in better. But over here, we're down here at negative 3. Okay, so my range is going from negative 3 to positive 3. And remember, when you give your interval notation, the smaller number is always on the left side. The bigger number is always on the right side. Just so you're not writing it backwards. Okay, the next graph. I do have a definitive starting point. So first of all, we're going to ask ourselves, is this a function? And we say, yes, it passes the vertical line test. Now for our domain are the x values. So I've got this point, and then look, I'm going to positive infinity. So I'm starting at negative 4, and I'm going to positive infinity. The range. This is a definitive low point on the y's. So I'm starting at 0 and including it, and it's going up, up, up. This graph is going to eventually rise, 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 and get higher and higher and higher. And so all those y values are found on there going in the direction of positive infinity. The next graph, is it a function? You say, yes. Y passes the vertical line test. Domain, remember the domain are our x values. Notice this arrow says this keeps going, so it's going to keep getting wider and wider and wider and eventually encompassing all of the x values. So we're starting and coming in at negative infinity. But when I go to the right, I see there's a definitive stopping point right here, and that's where x is 5. And it is included, it's closed dot, so it belongs to the graph. And so that's my domain. My range, I have to ask myself, is there a definitive high or low point? There is a definitive high point right here. Nothing is going to get graphed higher than that. The graph stops here and it keeps going in a downward fashion here. And so what is my range? Well, all of the negatives are going to, and it's not going to stop. All the negatives are going to be on there, so negative infinity. But no y value higher than 4 is going to be found on the graph of this function. It is a function, passes vertical line test. And so I'm negative infinity to 4, including the 4 on the range. Be sure to ask a question on the discussion or in class if you have questions on any of this. Determining the domain and range from a graph. Here I have a definitive starting point at negative 5. Is this a function? Well, sure, it passes the vertical line test. All right, what is my domain? Notice it's starting at a definitive negative 5. And I'm going in the direction of positive infinity. Notice the arrow. You know, these x values will be found on the graph of this somewhere down here. And so I'm going to infinity. The range. I need to know if there's a definitive high point or a definitive low point. This is a definitive high point. There is no definitive low point, which is indicating to me that it's infinity. But this is negative infinity. Notice this is the negative side. So I'm coming in at negative infinity. And I'm stopping at 3 and including the 3. Sorry about that. This is another linear function. It's a function. It passes the vertical line test. This is the graph of a horizontal line. So that's a y equals equation because there is no x. The slope is undefined there. Well, actually, this is a 0 slope. So this would be like y equals 0 times x minus 3. So is it a function? Yes. Why? Because it passes the vertical line test. I'm looking for my domain. Well, the domain are all the x's. I've got double arrows, okay, going left and right. So negative to positive infinity. And what's my range? Well, notice there's only one single value on the graph of this function. It's a y value of 3. Because here at this ordered pair, the y value is 3. 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 So there's only one single value of y found on the graph of this function. And so we can't write it in interval notation. So we're just going to write it in set notation. The range is 3 only. And our last graph, here I have a definitive starting point on x, a definitive ending point on x. Is it a function? Yes, it's a function. Because again, it passes the vertical line test. What is my domain? Well, those are my x values. Okay, so I'm starting at negative 4 and I'm stopping at positive 2. Keep in mind, you do have to look at your grid to be able to tell if you're going by 1s or 2s so that you have the correct starting and ending. So I'm starting at negative 4, including it, stopping at positive 2, and including it. The range, remember that's my high value and my low value. Do I have a definitive high value? Absolutely I do, right here, because the graph stops. And do I have a definitive low value? Sure, I do, right here, because remember, these y's are all the same value, okay? I'm not going to be less than a 2 in this case. And I'm not going to be more than a y value of 4 over here. So my range is going from 2 to 4, including both. So the first y value is 2. The second y value is 4. I'm including them and all the numbers in between. Right? All those numbers in between will be found on this piece of the graph right here. Okay? In other words, a y value of 3 would be found right here. A y value of 3.75, it looks about, would be right there, that y value. Okay, so that's why we have to give the interval, because it's not just 2 and 4, it's the numbers in between those as well. Okay, that ends this part of Chapter 2, Section 1. If you have any questions, please give me a shout out either on the homework discussion or in class. Have a great day.